Okay, so I'm Simon from ATELIC. I've been in oil and gas in upstream for the last 16 years. Various roles in digital twins and building AI models for various operators. And unfortunately, kind of the conclusion, or kind of the question that I kind of wanted to ask today is, in terms of digital twins, are we really driving operational change? Are we really changing how we run our operations? Are we changing our workflows? Are we really making a huge impact? And I want to discuss this. I want to discuss the gaps in applying digital twins in the field. And I want to see how we can leverage this emerging technology, AI, generative AI, to solve these gaps. So in this presentation, I'll be providing some concrete examples of how we've built solutions for this. The focus today is upstream, but what you see here in terms of architecture and what you see here in terms of deliverables, the concepts can be similarly applied to other domains in the upstream, can also be applied to other industries. Okay, so let's start. So the big push in oil and gas industry is to become more dependent on IoT data. So pushing sensors, increasing amount of data points, higher frequency. You take a typical upstream drilling operation, for example. You have over 200 real-time parameters streaming in. 30 to 40 of those are just surface parameters from the drilling rig. You have 8+ different streams. So this is from the LWD data from downhole. This is from the surface parameters. This is from the drilling control systems. Lots of different data sets, all telling you different things. 15+ document types. This varies between operator to operator, but essentially you will have data spread over PDFs, Word documents. These may be set and forget. These may be documents that are created once, like a drilling program, or these may be documents that are updated infrequently or frequently, like a daily drilling report, or something that's going to give you context for the operation in hand. What does this mean in terms of data? It means lots of it. It means over 1,000 variables for one drilling operation. What do we do, or what have we done? We've used systems like Kongsberg SiteCom. It's been an absolute classic in the industry. A lot of operations teams, engineering teams will spend most of their workday sat in front of a screen very similar to this, which is basically plotting real-time data on a graph. From this, you're just letting the human infer the relationships and trying to understand what's happening in the operation. This was the staple for the oil and gas industry for the last 20 years. In the last decade, we've kind of got Dashboard++, so smarter dashboards telling us more aggregated statistics, essentially data analytics applied to the operations. Then we've moved to kind of what I like to call is dashboard final boss, right? So you get something like this. This is what we call digital twin. This is a kind of a 3D render of an operation, sometimes with a physics-based model underneath it, sometimes not. So I'm trying to give you spatial data, right? This is what this does. It tells you what's happened and where it's happened. My question to you is, can we do better than this? Because does this really tell you about the underlying relationships, the causality of things that has happened? I don't think it does, and I would like to explore what we can do with this emerging technologies to try and develop that. So let's have a look now at the definition. There's plenty of definitions, but this is the kind of scientific definition of a digital twin, right? Live synchronization obviously should be mirroring via real-time data what the operation is doing. That's obvious. Dynamic modeling, typically physics-based models sitting underneath the real-time data, giving you a benchmark of what should be happening at any point in time during that operation. These are all bread and butter digital twin requirements. Then we move to predictive simulations and then prescriptive intelligence. What does this mean? This means looking ahead. It means what if. It means in the drilling domain, if I increase my mud weight by 2 points, what's my ECD going to be at total depth for this section? What impact will that have on me for the following sections? These are simulations typically not done automatically, and not done within the digital twin. These are done by manual steps by an engineer. He will collect all the contextual data, he will put it into a tool, an offline simulation tool, and then he will come out with the predictive reasoning and the outcome of what will happen if they change the parameters. Very manual process. I did it myself in the field many years ago. You're looking at many hours sat in front of a computer for one engineer doing one simulation to do one what-if scenario. I'll come back to that later about how we can use this technology to help that. Cognitive reasoning. So I was involved in some projects in Norway to try and build this into a digital twin. Without the technology we have nowadays, this is very difficult. You're basically doing boilerplate code of if something happens, then do this, and that doesn't scale, right? Absolutely doesn't scale, because each operation will be unique, each basin has different geology, etc., etc. Automate task and control. So you would really want your digital twin to be pushing automation, making decisions for you, implementing them, reacting. As we have today, this exists, but in small amounts. It's very difficult to do. The general trend that you see going from top to bottom of this stack is increasing complexity, right? So live synchronization, fine, dynamic modeling, this is very common nowadays. You go down that stack, it gets increasingly hard to try and deliver these, particularly when it comes to automation. This is very difficult. You need to be very closely attached to your asset and have a lot of data. The other piece is the ability to learn and update its logic. So enter the stage, obviously AI agents, right? So I've given you the base criteria for digital twins, but now we have the new era of cognitive reasoning, check. Automated tasks and controls, right? Automated workflows, check. The ability to update its logic. This is important because what we have with AI agents is we have a new memory bank that we can use, right? It's called context window. So we use that just like you would do as a RAM in the computer, right? You have a new place to store data, short-term, medium-term, long-term data if you want to use a RAG-based architecture. I'll go into architectural details later. But these things allow us to put inside the digital twin the story of what you've done. So you're not just looking at the real time, you're building that story of what you have done, right? And this is very important when it comes to reasoning. This is very important when it comes to understanding causality and what has happened. An example I will give you is you're drilling a well. You want to look at very complex dynamics such as hole cleaning. There's a few parameters that will indicate that you have hole cleaning issues. These are very small indicators that happen throughout the duration of the section. Using the cognitive reasoning and the historical context that you can add, these are the types of things you can pick up on, right? And this is really groundbreaking stuff. The other kicker that we have with AI agents is data parsing, right? A lot of conversations today about, okay, we don't have the data, it needs to be really formatted. Data parsing, so this is going into those operational documents that I mentioned earlier, those PDFs, those Word documents. You can extract those pieces of data, and you can pass that in a structured and unstructured way into your LLM. The development in this space has been massive over the last 12 months. Okay, so let's move it up again. So at ATELIC, we've been building these AI agents, and I will give you a quick summary of what lessons we've learned while we've been building them, right? The rubber has really hit the road at ATELIC, and we're really trying to be pushing the building here. So validation of your input data is priority number one. This is, if you're building AI agents, if you're building workflows, this should be where you spend most of your time. One word that I would need to tell you is semantic validation, right? That's very important. The other piece is avoid generalist catch-all agents. Keep your agentic workflows short. So agentic workflows are chains. The longer the chain, the easier they are to break. Build a system that is both autonomous and operator-driven. Make sure that there's a human in the loop. We've discussed this today. The verdict and the protocol was very clear. Human in the loop, informed always. And then the other point is agile architecture make sure that as the technology change, you change as well, because it's changing at a rapid pace. I'll very briefly go, because I'm out of time, very quickly go over the AI agent stack. Similar to Jean-Paul, we have a supervisor agent. It's ingesting all the data you see here from the left-hand side using the skill sets that I mentioned previously. We're connecting it to a digital twin that has the context of all of the parameters that you need. And then the supervisor agent has an army of sub-agents, SME specialists, dedicated to do very specific tasks. So for example, at ATELIC, we've built a natural language simulation tool. As I mentioned earlier, you can run multiple simulations automatically based on a prompt through an API to your preferred simulation vendor. You can run anomaly detectors, and you can look at global geology. These are just 3 examples. We have many more. This is an overview of the studio and the solution that we built. Essentially, 80% is framework, architecture. This is what we've built. The rest of the 20% is going to be on you, because it's going to be building on your workflows, your business requirements, right? That's an important point. When I give these lectures and I talk about what ATELIC is doing, a lot of people will say, Schlumberger is going to build it. Why not just go with Schlumberger? The pushback I would give to you is, this is your data, this is your business, and these will be your workflows. So you should integrate them and ensure that you derive the best value. Thank you very much. I'm Simon from ATELIC, and yeah, thank you for your time.